Hi everybody, this is BEA's R2E-100 and fly sensor webinar. First we'll start with a company and product overview. Agenda, company overview, request to exit sensors, fly R2E-100. Company, founded February 1965, leading manufacturer of presence and motion detection sensors for the automatic door industry. Worldwide representation, parent company, Halma Holdings, market capitalization, $1.5 billion, over 3,000 employees. Request to exit, fly, passive infrared, or PIR, a request to exit applications with mag locks or EL strikes, fast detection, adjustable sensing fields, no false detections from inanimate objects, 12 to 24 volts AC or DC, current consumption less than 10 milliamps or 20 milliamps with the relay activated. It's immune to electrical and radio frequency interference. Ships as a kit, includes the ceiling adapter, here, and surface adapter, here or here, with the choice of either white or black finish. Fly continued. The smallest and most accurate PIR motion sensor. Adjustable detection zone via masking lens. Operation temperature minus 22 degrees Fahrenheit to plus 140 degrees Fahrenheit. Supplied with 9 feet of 4-conductor cable. Here we have our surface mount adapter, ceiling mount adapter. Dimensions, overall 4 inches wide, 1.5 inches high, and about 1 inch deep. This is an approximate pattern with the sensor mounted at 7 feet high without any of the masking lenses installed in here. We'll see shortly. The approximate size, 8 foot wide by about 5 foot deep. Fly continued. Here's a breakdown of printed circuit board. This would be the cover that we saw on the previous side, which would be here. And then the masking lens here, kind of an exploded view. This is the masking lens fitting inside of the cover. This is a close-up view of the lens itself. You cut out the notches to shape the pattern. Cut them all out. You've got the maximum or the widest and deepest pattern. Fly, adjustments, and wiring. There are 3 dip switches. Number 1, the sensitivity, on or off, or high or low. Default is high. Dip switch 2 is a relay output, on and off. On is passive output, off is active. Default is set to active. Dip switch 3, hold time, on equals 2 seconds, off equals 1/2 of a second. 2 seconds is the default. Then we have another type of fly, looks exactly the same, part number is different, and the exception is extended relay time. The fly ERT has a 30-second or 15-second output relay hold time. The default setting is 15 seconds. Wiring terminals, pins 1 and 2 are your terminals necessary for power. So if you have 24 volts DC, pin 1 could be positive, pin 2 could be negative. 3, 4, and 5, that's your output. So you have your relay common, relay normally open on number 4, relay normally closed on number 5. So when the sensor goes into detection, we short 3 and 4, or we open 3 and 5. R2E-100 request to exit detector versus the competition. Here, an example, the sensor here mounted on the door header right above the door, looking down at the hardware. In this case, it looks like a lever handle for this type of door. And this sensor here, approximate pattern width 4 foot. So you can look to see which one is more secure, whereas here, this pattern is more of a convenience. Anyone walking by, not even if you're going to go through the door, could unlock the door inadvertently. Here, you're making a conscious effort to reach for the door handle and pull that or push that door open. R2E-100 request to exit detector has 3 auxiliary inputs: request to exit, card reader, and the door position switch. Has an adjustable sounder, activation LEDs. It's also UL 294 or UL Canadian S319 listed. 2 Form C relay output contacts for normally open or normally closed wiring. Operating temperature minus 20 degrees Fahrenheit to 120 degrees Fahrenheit. The pattern is only projected in front of the door and down to the door hardware, eliminating unwanted entrance. R2E-100 PCB angle and position. The PCB angle may be changed by repositioning it within the white plastic clips. Right in here. The white plastic clips allow the PCB to slide left or right for exact positioning over the door handle. So you can see here the little cuts or even little kerfs in here. You can put the PCB board in there and change the tilt angle of the sensor. Also, these can slide left and right within the housing to specifically locate the pattern. R2E-100 LEDs. Green is on, running, and no detection, or on and powered, no detection. Red, object in detection or input activated. In this example, i.e. hand in the detection or a request to exit asserted. Yellow LED, the relay is active by relay hold time, relock mode set via dip switch 2. Flashing orange, sensor or inputs in constant detection greater than 10 seconds. R2E adjustments. Potentiometers. There are 3 potentiometers, here, 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 1, 2, and 3. The detection range, R and G, rotate to adjust the detection range distance. Relay hold time, time here, rotate to adjust from 1/2 to 60 seconds. Alarm volume, here, VOL, rotate to adjust from 70 decibels to 100 decibels. Dip switches, here, dip switch 1 for fail safe or fail secure. Number 2, relock mode, door position or timer mode. Dip switch 3, door position mode, block time. Number 4, hold time, restart or countdown. Number 5, alarm on or off. Number 6, card reader input on or off. Number 7, alarm based on card reader input. And number 8 is for future use. R2E-100 electrical inputs, outputs. Red and black wires are used to power the unit. You got to have both of those to power the unit. If you have AC, one conductor goes to red, the other conductor goes to black. DC, red typically would be positive, black would be negative. But if you do nothing else, these 2 wires are needed for power. Relay 1, common, normally open, normally closed. Relay 2, common, normally open, normally closed. A dry card reader input, blue, blue with the white stripe or white tracer. A dry request to exit input, orange and white with the white stripe. Dry door position input, brown with the white stripe. Dry meaning no voltage. Just a relay, just a dead short, no voltage. BEA's R2E-100 versus the competition. I'm not going to read everything here, or maybe anything. R2E, parallel traffic rejection. Yes, these brands, no. And this, the sensor reduces the false detections, increasing security. That's due to the specific pattern size of the product. Here, a request to exit input. Yes, the BEA R2E-100 has that. This brand, no. This brand, no. Okay, we'll move on. And that's it. Tech Services has a general email. You can email everyone in Tech Services for technical related questions. That email address is tech_services@beainc.com. tech_services@beainc.com. We also can be reached at 800-523-2462, as well as sales and warranty information, pricing as well. Stand by. We'll bring you back online.